Hello, welcome back. Let's go ahead and take a look at basis and dimension. So, what are these things? Well, first off, we saw last time a little bit about basis. So a basis, let's remind ourselves that a basis is a linearly independent set, meaning there's no extra information, that spans a vector space. And today we're going to be introducing the topic of dimension, which is the dimension of a vector space is the number of things that you need in any given basis of a vector space. Is the number of elements in any given basis. And the great thing is that this number is always going to be the same. Given basis. Which I want to very strongly encourage you to take a look at the proofs in the book regarding the existence of the dimension. Because we can't have a dimension if we don't know that every basis is going to have the same number of vectors. That would just make it not well defined. Alright, so let's go ahead and look at this particular example. So I've just picked out a random vector space that is a subspace of polynomials of degree up to 3. And I've chosen some sort of representation of all of the elements. And we know that we have 3 scalars that we can associate to the elements. So one way to figure out the dimension is to find a basis. And how are we going to do that? Well, if we have our general form, minus 2ax squared plus 3cx cubed, we essentially want to be able to write this as a combination with scalars of some particular vectors or polynomials in P3. So we rearrange this so that each of our scalars A, B, and C are outside. So A is multiplied by both 7 and minus 2x squared. B is multiplied only by 6x, and C is multiplied only by 3x cubed. So off the bat, it looks like our basis is 7 minus 2x squared, 6x, and 3x cubed. Oops. Curly brace. And we do want to check that these are linearly independent. It's pretty clear here that they are because we have a x squared, and no x squareds in the other terms. We have a constant term, an x, and an x cubed, all sort of pushed separately, so there's no way to write any of these as a linear combination of the others. So let's say no way to write these, any one of these, as a linear combination of the others. Because we don't have the right powers of x anywhere. So this tells us that we're linearly independent. And then what we might notice from what we were messing with above when we were first figuring these out, this star here is why it spans the whole space. So therefore it is a basis, so we can conclude, since this has 3 things in it, therefore the dimension of W equals 3. And that's that. It's that easy. You just have to find a basis, verify independence and spanning, and there's your dimension. Alright, that's it for this video. Have a good one. Bye-bye.